and welcome to the Aerospace Testing Podcast. I'm the editor of Aerospace Testing magazine, Ben Sampson. This month I talked to Norris T, co-founder and CEO of Exosonic, a US company developing a low-boom supersonic jet that's capable of cruising at Mach 1.8. You may have first heard about them through their partnership with the US Air Force to produce a supersonic Air Force One aircraft. Norris has been working in the aerospace sector for the last 4 years on vehicles that fly faster than the speed of sound. He's worked as a propulsion engineer at Northrop Grumman, then at the Spaceship Company, and then Lockheed Martin. As you'll hear in the podcast, he's been passionate about supersonic commercial flight from a very young age and has dedicated his career to making it happen. We discuss where Exosonic is with its aircraft development program, what the partnership with the US Air Force has meant for his startup company, the connection between Exosonic and Lockheed's X-59 experimental supersonic aircraft, as well as some of the major technical challenges that still remain for passenger supersonic aircraft. By the way, Norris will be appearing at our London to Sydney in 5 hours, the Future of Aviation conference in London next month. For more details and to register for the hybrid event, go to www.londontosydneyinfivehours.com. I'll say it again, it's www.londontosydneyinfivehours.com. I hope you enjoy the podcast. Hi Norris, thanks for making the time to speak to me today. Norris, you are CEO of Exosonic. You mind just starting telling me a little bit about your journey to starting the company, and then a little bit about what the company's objectives are?
Yeah, sure. So I've been really passionate about faster transportation for a long time, ever since childhood, due to my own frustrations traveling across oceans and other long-haul flights, and wishing that they were faster. And so in the late 2000s, when I was around high school, I thought, well, there's no way that commercial aviation is going to remain the same forever in terms of flight times, and that it's going to get faster over time. And then so from that point on, I dedicated my academic and professional experiences to figure out faster transportation solutions. So I studied aerospace engineering, worked in the industry for a couple of years, all on vehicles that break the sound barrier, from hypersonics to rocket engines, and finally supersonic aircraft, again, specifically low boom airplanes at Skunk Works on the X-59 program. And then after my industry experience, I thought, well, low boom supersonics is the future, right? I mean, the main issue with the Concorde was its inability to fly supersonic over land, and that ultimately led it to only fly on two routes on a regular basis. Then I went to business school to pursue this idea and started Exosonic while I was more or less still in business school, with my co-founder, Tim McDonald.
Cool. Okay. And what exactly is the aim with Exosonic? I mean, how far are you hoping to go with your development program?
Yeah. So we believe that for any commercial supersonic airliner to come to market, it's going to have to be developed by most likely a startup. I'm not sure if the incentives are in place for the large incumbents to develop a supersonic airliner. They have certainly enough products on the subsonic side to keep them busy. And so in terms of Exosonic's journey, we're focusing on low boom supersonics. And we want to develop a supersonic airliner to enter service in the early to mid 2030s timeframe. We understand that it is quite a long-term and capital-intensive project, and we're actually breaking down our vehicle development into a few smaller products in the short and medium term that will help us develop technologies and revenue to get to the supersonic airliner. We haven't talked too publicly about some of those near-term solutions, but in the coming months, we hope to release something more about that.
So the key there is that you're taking it bit by bit, part by part. You're not tackling the whole problem head on all at once, right?
Right. And I think a successful analogy here is certainly SpaceX, right? I mean, Elon Musk and SpaceX have always said they wanted to go to Mars, but they didn't start with a Mars rocket. They started with a very small rocket called Falcon 1, and then built that up over time to become Falcon 9, and now all the Starship tests that we're seeing in Texas. And that's that crawl, walk, run approach that we also want to take to achieve our big vision, which in this case is supersonic travel everywhere by meeting the sonic boom.
Okay. Well, I mean, you've worked on the Quest plane, right? That's on the aircraft, yeah?
Yes, I did. I was a propulsion engineer for that program.
Okay, so I mean, how similar is the aircraft that perhaps Exosonic might one day develop going to be to Quest? Is there a lot of share between the programs, or?
I mean, I think the underlying technology will be, similar, right? Because we're going to use muted boom shaping techniques on our supersonic airliner and our vehicles in general. And so that will be certainly a big crossover. I think another interesting piece is that forward vision system that they have too. One thing about supersonic aircraft in general, and even more specific with quasi-supersonic airplanes, is that they have a very long nose. And so the Concorde had that droop nose, and that allowed pilots to see during landing. And so what we can hopefully do with the right certified parts and everything is that we can just have a camera system that allows pilots to see the runway as they're coming in.
Okay, sure. So I mean, there's a lot of new tech obviously involved in this area. A lot of new aerodynamics work. I mean, a lot of that is happening with Quest before Exosonic get further down the road with your program. I mean, are you kind of, does the success of Quest kind of depend on, how much is your success dependent on the success of Quest? Is that an uncomfortable question? Sorry.
No, I think that's a very legitimate question. I mean, I would say the X-59 and Quest, or Quest program, it's certainly really important, right? We want the team to succeed because it will help open up regulatory doors, not only in the United States, but hopefully in Europe and across the world, right? The whole point of that program is to fly over communities, boom them with their quieter boom, and see if people find it annoying, right, or burdensome, and do that not only, again, on a national scale in the United States, but internationally as well. Now, if the X-59 program fails for whatever reason, then we also have backup plans where we can pick up where they left off through our own smaller vehicles that are also going to meet the sonic boom.
Okay, so I mean, you mentioned that you're breaking down the program and that you're taking it piece by piece, which seems sensible. I mean, where are you now exactly with development? I mean, what have you achieved so far?
Yeah, so we've certainly focused on the supersonic airliner lately, in the past basically 2 years or so. And just strategically, we're starting to shift a little bit towards our smaller supersonic products. Now, of course, we've been working on the supersonic airliner concept because of our Air Force contract to develop an executive transport version for top US leaders. And so as part of that, we've done the cabin interior layout, as you may have seen from various articles online, in addition to a wind tunnel test that we did at University of Washington. And the point of that test was to understand the takeoff and landing characteristics of our supersonic airliner, because that's certainly a really difficult part to understand given the aerodynamics at those speeds and given the configuration of our airplane. And so we continue to do some of that testing in addition to doing the aircraft conceptual design work. And we want to close that conceptual design work off, and that will complete our Air Force contract, and then we'll transition to some of our shorter term solutions.
Okay. You mentioned the Air Force contract. Yeah, I mean, obviously quite a big deal for you guys. Probably got a huge headlines, not just in the lowly trade press where I am, but it's quite. I mean, how important was it to the company? I mean, how much is it really impacting what you're doing and even the development process itself?
Yeah, I mean, it's been monumental. I would say, if I can put it in a word, and especially this was like near the beginnings of the pandemic, right, where commercial aviation industry and every industry was really hurting, and this came out of nowhere, but it came at the appropriate time, and it really helped launch our company. I mean, it literally did launch our company to the world, if you will. So it's been really helpful in that way. But in addition to that, I mean, it helped us develop more relationships within the U.S. Air Force and the federal government at large, which is going to be helpful down the road, right? I mean, as we go into flight tests later down the road, or talking about other solutions that we can use supersonics for. I mean, these are all really great ways that this Air Force contract has helped us.
So, Norris, you mentioned that it's been a personal ambition of yours to kind of overcome the to shorten the time that it takes to get places on an aircraft. There's some critics would say that we don't really need to go much faster in aircraft, and in fact, there's sustainability considerations to do with that perhaps we shouldn't be designing these kind of planes at all. I mean, in a long way around, I'm asking you. I mean, are you thinking about that now? The sustainability, environmental considerations of the aircraft that you're developing?
For sure, yeah. Sustainability is a huge thing that we want to tackle as well and address for our supersonic airliner. I mean, if we don't have a sustainable solution, we just don't have a solution in general. And when we talk about climate change, right? I mean, it's like my generation that is going to really live through the impacts of climate change. So I don't want to make it any worse for my future family and the posterity beyond that. So it's something that we really think about. In terms of our supersonic airliner, I mean, we've talked to some engine manufacturers, sustainable aviation fuel providers, and for better or for worse, those are the near-term solutions to providing more sustainable commercial aviation in general, right? And we certainly want to use 100% SAF and be as carbon neutral as we can, and hopefully GHG neutral as we can too, as technologies evolve over time. So it's certainly a consideration that we have, and we certainly prioritize it up there, of course, with safety.
Okay. Let's see. I mean, I think you've put 10 years through to certification. Is that right? Are you still standing by that from when you launched, or what was?
So we're saying early to mid 2030s for our supersonic airliner to enter commercial service.
Okay. So that's seems reasonably ambitious, I'd say. I mean, can you give me any more details on your kind of roadmap to that point at the moment? I mean, what's your next milestone?
Yeah, so it's really predicated on some of these smaller supersonic products that we want to develop over time. It's kind of like what we talked about earlier about the crawl, walk, run approach, and we want to develop these smaller technologies that can fly, that can not only build revenue but de-risk a lot of the technology that goes into the supersonic airliner. And so that would include some flights, of course, in the near term, like the next couple, no later than 5 years time frame.
Okay. So what sort of technology? Can you tell me what sort of technology, what parts of the plane you'll be testing in that kind of time frame? Or?
Yeah, I mean, we need to certainly develop a supersonic aircraft in that time frame.
Yeah.
So that's what we're looking to do, and we test out some of the low boom aspects of the vehicle.
Okay, sure. All right. Mm-hmm. I mean, and then during that 10 years, what are your plans to also kind of growing the staff and the capabilities of the company? I mean, how many people have you got at the moment, and what could you get up to, do you think?
Yeah, we have eight full-time folks right now. Mm-hmm. And then we certainly want to double in the next year or so, and then continuing our company's growth over time. I mean, if we benchmark to some other companies, by 2020, mid to late 2020s, we'll probably want to have a couple hundred, like 400, 500 employees working on our various product lines.
Yeah. Okay. Sure.
And of course, the supersonic airliner.
Mm-hmm. It's quite a scale up then. Yeah. Okay. It's very ambitious. Mm-hmm. All right. Well, let's talk quickly about the more fun stuff, the kind of techie aspects of what you're doing, and mm-hmm. Let's. I mean, from a design and testing point of view, I mean, there must have been a lot of work that's going on the computer screen so far. I mean, you mentioned the wind tunnel testing earlier on. I mean, what kind of tools are enabling you to design and develop the aircraft and the aircraft's technologies in this way now?
Yeah, for sure. So like you're saying, a lot of the tools are computer-based, or a lot of the testing can be computer-based, right? And that's because a lot of these software have been developed over the past couple decades, and there's been a rich history of a lot of supersonic aircraft testing, whether that be wind tunnel testing for aerodynamics, propulsion systems, or flight tests, right? That have just as a whole help the industry move forward. And so we've benefited a lot of that and been able to base some of our tools off literature or even our own wind tunnel test data. So that's been really helpful to design, use these pretty mature tools. Of course, we pick the right tool for the right level of fidelity that we want to cycle through the aircraft design quickly and as accurately as we can for the fidelity that we want.
So how much confidence do you have in that sort of carryover from that point? I mean, obviously, with any kind of simulation, there's a point when you have to validate, right? And so, how much confidence have you got that when these ideas around low boom aerodynamics are, eventually flight tested, that they will be borne out and that we'll get the results that we want?
Yeah. So, I mean, as far as I'm aware, for the X-59 program, they did not do any wind tunnel testing to prove the low boom aspects of the vehicle, right? They're just going to go in the air. I mean, NASA has done some of that stuff in the past on the N+2, I'm not sure the N+2 programs, but certainly N+2 programs, where they put microphones in a wind tunnel and had this very, very small model that and put supersonic air over it to capture some of the near field pressure distributions that were captured on the microphones. And that was used to validate some of the shape sonic boom tools that NASA developed. And so as far as I'm aware with the X-59 program, I mean, having not seen that program do any of that sort of microphone testing in a wind tunnel, that tells me that they've just done a completely computationally, right? And they're going to actually go fly that vehicle and change regulations based off computational tools.
Yeah. Okay. Right. I mean, are there any other kind of fundamental technologies that you think that you need to get right, that need to be right in order to make supersonic happen in the way that your company wants it to? I mean, I'm thinking in terms of materials or propulsion.
Yeah. I mean, the thing is, we've been flying supersonic aircraft for decades, right? And we want to keep things as conventional as possible, just given the nature of the challenge already, right? I mean, one of the things that the Skunk Works team says and have said in the past is like one miracle per program, right? And once you start using all these new technologies, new materials, new propulsion systems, et cetera, you introduce a lot of risk that may be unnecessary and may lead to ultimate failure. So we want to keep things as conventional as possible and only take the risk when it's absolutely necessary. So in terms of the testing, right, it's like we want to make sure that we can validate what we are uncertain about. But for other things where there's a lot of heritage knowledge about it, maybe we don't need to do the validation because there's already, people have already done that for decades for us, and we can benefit from that.
So it seems funny to talk about what is looked at as such a new type of aircraft by so many people, but to think that so much of the technology in it is already accepted and in use and validated. I mean, how much would you say? How much would you say is like that in the aircraft? 2/3, 80%, less? I mean, I
would say a lot of it. A lot of it has been proven in some form or fashion in other vehicles, right? I mean, again, we've been flying supersonic airplanes for a long time. Now, composites versus metallics for the airframe. I mean, we probably want to stick with metallics in the early stages, just given how, composites, that you have to build up a lot of knowledge for that to happen. And very few companies can do that, right? Like Boeing obviously can, because they spent, I don't even know how many hundreds of millions of dollars developing their database, right? The metallics are pretty well understood at this point, so maybe we'll go in that direction. The engine, I mean, we're at the early stages, we'll get an off-the-shelf engine, and that would really help. And, developing flight control systems for supersonic airplanes is pretty well understood. So that's pretty great. And low boom, like we talked about, that's been proven in flight tests for some programs like the Shape Sonic Boom Demonstrator in the early 2000s. And the X-59, again, is being designed through computational tools, right? So that gives us a sense of the technical maturity of those tools. So there's not much from a technical or technology standpoint that's risky per se. It's just about the integration of all these known technologies into a new platform, and that's really the risk.
Yeah, that's exactly what I was going to say. It's kind of fairly typical of this kind of project, almost like a 21st century project that we're integrating all these different things in a new way, and
Right.
right, and that's where the real challenge is.
Right.
I mean, is there anything else from a testing perspective, really? I mean, I know you might be a ways off putting stuff in the air yet, but is there anything from a testing perspective that kind of, an engineer might find working in that area might find interesting, or that perhaps you really worry about at the moment as a big challenge?
Yeah, I mean, there's a lot of different forms of testing that are done on airplanes, right? I think the most typical one people think about is wind tunnel testing. But I mean, there's ways that you test structures. There are ways that you test the flight control systems, like an iron bird or like software in the loop, hardware in the loop type system. And those are all tests that we would like to do going forward. And of course, the ultimate test, which is flight test. And for that, we would certainly want to put microphones on the ground and then have this vehicle fly over, supersonic these microphones and capture the sonic boom signature. And that would be the thing that we're most, I guess, apprehensive of, if you will. But this is basically the highest value test that we would want to conduct in the near term.
Okay, right. I guess if I could just finish up, just a couple of quick questions, Norris, just to finish up. One of them is a little bit cheeky, I guess, but it's to do with, I mean, what gives you faith that there will be a market for this aircraft when you eventually arrive at that point, or some of the technology around it even?
Yeah, I mean, I think fundamentally people want to reach their destinations faster. Right. I mean, think about these, what do they call, sunset sunrise flights from like Australia to London. I mean, the whole point of that is to see if people are willing to shave off a couple of hours and make a direct flight versus doing, a few stops at the, to get from Australia to London. So I think fundamentally people want to go faster, right? And that's really the value that airlines and any transportation companies providing, whether that be cars, scooters, right, trains, etc. And so from that angle, I think there will be demand. And I got to say, Boom certainly has done a good job at raising demand from various airlines around the world. And so, if anything, that is an indication of the industry's interest in that. And there's obviously challenges that we need to overcome, like sustainability, profitability, just regulations and things like that. That we'll continually work on over time. However, if we can solve those challenges, then yeah, I'm sure passengers will want to pay. I've flown across the United States many a times, and I would love to have a 3-hour flight versus a 6-hour flight.
Yeah. Okay. Point taken. Yeah, I appreciate that. And just finally, just quickly, do you think that? I mean, I don't want to put it in terms of a race to market because it's such a hack thing to say, but do you think that do you think we'll see another who do you think will be first in the race to market with these? Will we see a little business jet first, or will we be straight in with airlines? What do you think will be the first application?
I mean, for the biz jet contenders, I think there's only one now. I mean, it's really just Spike, and I really haven't seen anything from Spike. I mean, that's kind of been the CEO strategy to be hush hush, but I really can't gauge where they're at. So from what I understand from market intelligence, right, it's going to be a supersonic airliner, and we're betting Exosonic will be the first to market. I know Boom has been ahead, but yeah.
How do you find the sort of the sort of community in the US and maybe even globally around sort of supersonic passenger? And do you think they're quite collaborative and prepared to work together on problems, or is it very competitive?
I mean, from the aircraft manufacturing perspective, I don't think it's very collaborative, just due to the nature of the technology. It's certainly pretty close to defense, right, given the supersonic applications of supersonic airliners. But from a regulatory standpoint, I mean, it has to be international. There has to be international collaboration, just the fact that these aircraft will be flying internationally.
Yeah, okay. All right, So I hope you enjoyed that podcast, that interview. Some fascinating insights there from Norris. Thank you, Norris, for your time, and thank you for listening, downloading, and listening the podcast. I'm sure, like me, you get the feeling that Norris and Exosonic are going to be an important part of passenger supersonic aircraft development in the 21st century. So keep a lookout for our next podcast, which will be a chat with CEO of Jetpack Aviation, David Malins, about their new speeder eVTOL. Thanks for listening, and have a great day.